Hello students, so this is next tutorial on the same chapter differentiation. In the previous video lesson we were learning how to differentiate an implicit functions. I have received few questions that the students are facing problem, so that those questions we will be solving today, and hopefully you are practicing at home, and whatever doubts you have you will let me know. You will send me my WhatsApp number so that I can solve those questions. So let's start today's class. So you see, first question, y equals to y sine x. Differentiate this one. We have to differentiate with respect to x. So when you differentiate d dx of y, here you have to apply uv rule, right? So y d dx of sin x plus sin x d dx of y. d dx of y d dx of sin x is cos x plus dy dx sin x. So dy dx term we will be taking in one side. Dy dx already it was there, minus d dx sin x equals to y cos x. d dx of y can be taken common. We will be getting here 1 minus sin x y cos x, or d dx equals to y cos x by 1 minus sin x, right? So this is our final answer. So in the previous question we saw y equals to y sin x, okay, but if the question gets changed, if you have y equals to x sin y, then in a similar way we will be differentiating. Now we will consider x as u and sin y as v, okay. So we know the formula of product rule, u d dx of v plus v d dx of u. Same formula we have applied in the previous question also. So here we see d dx of y, x d dx of v, v means here sin y, plus v means sin y, d dx of u, you will consider as x, right? X d dx of sin y can be written as cos y, again d dx of y, okay. So now we have to differentiate. Previous question there was a d dx x was 1, but here we have y, so d dx of y you need to write once more. Sin y d dx of x is 1, so x cos y dy dx plus sin y, here d dx y term we have to take in left hand side. So already we have 1 d dx y minus x cos y d dx equals to sin y. Now d dx of y can be taken as common here, 1 minus x cos y equals to sin y, or d dx of y can be written as sin y by 1 minus x cos y, okay. So this is our final answer, okay. We'll move to next question now. You see, I have noted down few questions here, so that we will be solving. These questions are from exercise 8H, that is the implicit function, which we have solved few questions in the last video. So these questions also I will be giving in your WhatsApp group, so you will be practicing, okay. Unsolved question you will practice, and the doubts which you get you will let me know. Next question, what is given here? Y equals to, or y log x equals to x minus y. Prove that d dx of y equals to log x by 1 plus log x whole square. So we will differentiate directly here, differentiating both sides with respect to x. Now here we have to apply uv rule, okay. I will write the formula here, that is d dx of uv, that is u d dx of v plus v d dx of u. So this formula will be applied in most of the questions here. So y d dx of log x plus log x ddx of y, apply UV rule here. Now ddx of x is 1 here, ddx of y ddx of log x is 1 by x plus log x dy dx equals to 1 minus dy dx, right? So dy dx term to be taken in one side, log x dy dx plus dy dx 1, this will be coming in other side, that is y by x, y into 1 y by x will be coming in other side, that will be minus y by x. Now dy dx term will be taken common here, so we will get here log x plus 1 equals to, if you take LCM here, x minus y by x, or dy dx can be written as x minus y x 1 plus log x. You see, we got the ddx y term here, but it is not matching with the right hand side, so we have to take some substitution here. From the question you see x minus y can be written as y log x, right? So in place of x minus y, first I will substitute y log x. So if I consider this one has to be equation number 1, so x minus y by x1 plus log x. This is from 1. I'll let here from 1. Okay. Now you see, here we have x and here we have log x square, 1 plus log x whole square. So this x also we have to substitute. So in the question it was given x minus y equals to y log x. So x can be written as y log x plus y. This is from equation 1, okay? That is the equation which is given here. So y can be taken common here, 1 plus log x, that is x. So now let it be equation number 2. So again in place of x we will substitute this value here, or let us consider this equation number 3 and this equation to be as 2. From equation 2 and 3, dy dx, this is the dy, this equation we will be writing here, dy dx equals to y log x by, now in place of x we will be substituting here y 1 plus log x, and already 1 plus log x is there, that is 1 plus log x whole square. Now y and y will be getting cancelled, so our answer is dy dx equals to log x by 1 plus log x whole square. Okay, so this is our final answer, which is equals to RHS. Okay, so in this type of question, first we will be differentiating both sides, and wherever the ddxy term is there, we will be taking to other side and we will be taking common. If cross multiplication is required, you will cross multiply, then you will see whether it is been proved or not. If it is not proved, then we have to write from the first equation. We have to change some terms here and we have to substitute in that given equation. Okay, so this is how we will be proving. We will go to next question now. Next question we have used here, x equals to y log xy. Again here ddx are differentiating both sides with respect to x, that is ddx of x, y ddx of log xy. So this is our u and this is our v. Okay, applying the same formula here, plus log xy ddx of y. ddx of x is 1 here, y, now ddx of log xy is 1 by xy. Again we have to apply differentiation, now we have to apply here product rule, plus log xy ddx of y, that is dy dx. Okay, so y and y gets cancelled, 1 by x, now here we will apply again product rule, that is x dy dx plus y ddx of x is 1, so I am not writing it, plus log xy dy dx. Multiply this one, x, so 1 by x into x dy dx plus y into 1 y by x plus log xy dy dx. X and x gets cancelled here. Now from these two terms I will be taking dy dx as common, so we'll get here 1 plus log xy plus y by x as it is. Here in the left hand side we have only 1 here. Now this term y by x will be coming in other side, that is 1 minus y by x equals to dy dx 1 plus log xy. We will take LCM here, that is x minus y by x dy dx 1 plus log xy. And one more last step, that is dy dx will cross multiply now. This will come, nothing there means 1 will get multiplied with x minus y will remain same, and this will come in denominator 1 plus log xy. So we are keeping it as it is, okay, because we don't have to prove here. The previous question we had to prove, or in this question here we don't have to prove anything, so we will keep it in this way only, right? Next question we move. Question number 3, sin x plus y equals to log x plus y. Now in the left hand side we have sin and right hand side we have log. So ddx of sin x, we know it is cos x, and ddx of log x is 1 by 1 plus x plus y. So same formula will apply here, differentiating both sides with respect to x. ddx of sin x is cos x plus y, again ddx of x plus y. Okay, I have done directly differentiation here. I have not noted down differentiating both sides with respect to x, so you will be writing that one. Again ddx of log x plus y is 1 by x plus y, again ddx of x plus y, right? So you see in each and every question we have to differentiate y twice. So here that comes under implicit function. So cos x plus y ddx of x is 1 plus dy dx, 1 by x plus y ddx x is 1 plus dy dx. So this one we have to multiply within the bracket, cos x plus y into 1 cos x plus y plus cos x plus y dy dx. Similarly we will multiplying here, we will get 1 by x plus y plus 1 by x plus y dy dx, right? Now dy dx term to be taken in one side, same question, same way what we have, how we have solved in the previous question. So dy dx term to be taken in one side. So cos x plus y dy dx minus 1 by x plus y dy dx, 1 by x plus y, this will come in another side, that is minus cos x plus y, right? Now we will take dy dx common. So if you take dy dx common, then we will get cos x plus y minus 1 by x plus y, and if you take here LCM you will get 1 minus x plus y cos x plus y by x plus y. Similarly here also if you take LCM, then here if you take LCM, that means dy dx x plus y cos x plus y minus 1 by x plus y, and right hand side we have 1 minus x plus y cos x plus y total divided by x plus y. So x plus y and x plus y will get cancelled. So you see here x plus y cos x plus y minus 1. So if I keep it as it is, and in the right hand side, if you change the sign, if you take minus common, then 1 will become negative and this one will be positive, that is x plus y cos x plus y minus 1. Understood? Here I have taken minus sign common and plus 1 became negative 1 and this negative term became positive. So you see now both the terms are same here, this and this and will get cancelled. So ddx will be minus 1. So this is our required answer. Okay. So these are the few questions in which some students were facing problem. They were asking me to solve those questions here. Next question we have, you see, in terms of square root of log x plus root under log x plus root under log x to infinity. That is this term, log x term, root under log x term is repeating again and again. For this type of question, we will be taking substitution. The part which is repeating again and again, that one we will consider as y. Question number 4. If y equals to log x plus root under log x plus root under log x plus up to infinity, this root under term is repeating again and again, we have to prove 2y minus 1 dy dx equals to 1 by x. Here we will take, let root under log x plus root under log x plus dot dot infinity equals to y. So substituting this in the question, we will get y equals to log x plus y. Okay. So this all term I have taken as y. Now squaring both sides as bs. If you square this one, you will get y square and log x plus y whole square. So square and square root will get cancelled. We will get y square equals to log x plus y. Now differentiating both sides. When you will differentiate, first you will get 2y dy dx. Dx log x is 1 by x plus dy dx. Now dy dx term to be taken in one side. 2y dy dx minus dy dx equals to 1 by x, or dy dx can be taken here common. If I take common, we will get 2y minus y equals to 1 by x equals to RHS. Okay. So this is how we will prove few questions here. One more question we have in terms of cos, that one you will be solving by yourself. I will be giving in your WhatsApp group. So next exercise we have parametric functions. So I have noted down here a few questions from this exercise, and hardly there are 6 or 7 questions are there, and the rest questions you will be solving. Just I will give you a brief idea how to solve some questions from this exercise. You see, first question we have x equals to ct and y equals to c by d. We have to find ddx of y. Okay. So parametric means now x and y functions are given separately. First we have to differentiate separately, then we have to combine. Okay. So x equals to ct. Now you see we have two variables here. So c always you will consider as constant. T is the variable here. Okay. Similarly here t is the variable, c is the constant. So when you differentiate x equals to ct, differentiating both sides with respect to t. So ddt of x will be c ddt of t, that means c is the constant, so I have kept outside. So ddt of t is 1, like ddx of x is 1, ddt of t is 1. So c into 1, that is c. Okay, so this one part. Now this one we will also differentiate, t to the power minus 1. So c by d, t can be written as t to the power minus 1. Now again we will differentiate with respect to t. Okay, differentiating both sides, same here with respect to t. Now c ddt of t to the power minus 1, minus 1 comes front, t to the power minus 1 minus c t to the power minus 2, or minus c by t square. So here we got dy dt, right? So this is our equation number 1, this is our equation number 2. We need to find dy dx. So dy is in numerator and dx is in the denominator. So what substitution, what variable we have taken here? T. So we multiply here dt and dt, right? So if you cancel dt and dt, we will be getting dy dx. So So dy dt is minus c by t square into dt by dx. You see here dx by dt is c. So dt by dx, if you reciprocal, then what you will get? 1 by c, because c by 1 was there. If you reciprocal, 1 by c. So in place of dt by dx, we will be substituting 1 by c. So c and c got cancelled. So 1 by minus 1 by t square. So this is our required answer. Okay. So similar way, we have few questions here. You see, this is also given in terms of x, in terms of y. Now here variable is theta. So we have to differentiate both the equations with respect to theta. Then we will be finding dy dx. Okay. So we will go to next question here. Question number 2, x equals to, better I will write in 2, how that is x equals to a theta plus cos theta, and here y equals to a 1 minus cos theta. So this one we will be solving with respect to theta here, that is dd theta of x, a is the constant part, dd theta of theta 1 plus dd theta of cos theta minus sin theta. Okay, or this can be written as a 1 minus sin theta, that is ddx of d theta. Let us consider this equation number 1. Similarly, differentiating both sides with respect to theta, dd theta of y a, now dt theta of 1 is 0 minus dd theta of cos theta is minus sin theta. So a minus minus plus, that means a sin theta dy d theta, right? This is equation number 2. We need to find here dy dx. So dy is in numerator and dx is in denominator. So what we have taken here, theta, that is d theta and d theta to be multiplied. Dy by d theta, we have a sin theta into d theta by dx. We have dx by d theta. So d theta by dx can be written as nothing is there, is 1. So if you take reciprocal, you will get 1 by a 1 minus sin theta. So here 1 by a 1 minus sin theta. So a and a got cancelled. So we got here sin theta by 1 minus sin theta. Okay. So next question. Next question we have x equals to a cos t plus t sin t and y equals to a sin t minus t cos t. So same way we have to differentiate both sides here with respect to t. Now ddt of x equals to a, now ddt of cos t is minus sin t, plus now here we have to apply uv2, t ddt of sin t plus sin t ddt of t. Okay, so dx dt equals to a minus sin t plus ddt of sin t is cos t, that means t cos t plus sin t. Okay, so plus sin t and minus sin t got cancelled. So we will get here at cos t dx dt. Okay, so this is equation number 1. Similarly, we will be differentiating this one also, that is ddt of y, a ddt of sin t is cos t minus, here we will be applying uv rule. So here we will be using one bracket here, that is t ddt of cos t plus cos t ddt of t. Ddt of y a cos t minus, now you see here ddt of cos t is minus sin t, so minus minus plus, t sin t minus plus minus ddt of t is 1, so here we will get cos t only, so minus cos t and plus cos t got cancelled, here also we will get at sin t. Okay, this is our equation number 2. Now we find ddx of y, that is dy is in numerator and dx is in denominator. We have taken here t, that is dt. Now we will substitute all the values of dy dt and dx dt. So when you substitute here, that is dy dx will be dy dt, we have at sin t into dt by dx by dt, we have at cos t here. So if you take reciprocal, then what we will get here? 1 by at cos t. So at and at got cancelled, sin t by cos t is left here. So sin t by cos t is tan t. So this is our answer. Okay, so this is our final answer. So these are the few questions from this exercise, and the rest 3 questions or 4 questions that is left, that one you will be solving by yourself. So this is the next exercise, that is differentiation of a function with respect to another function. Here in this exercise we have two functions and we have to differentiate x squared with respect to x cube. So whenever any question it is in with respect to this function with respect to another function, so one function will be taking as in terms of u and other function will be taking in terms of v. For example, here we have question x squared with respect to x cube. That means we will be taking u equals to x squared and v equals to x cube. It is not mandatory that you have to take u and v only. You can take other variables apart from x. Okay, so u equals to x square and v equals to x cube. Now this question, it has become like parametric functions in the just we have seen in the previous questions. So this one we have to differentiate with respect to x. That means du dx will be 2x, right? Here dv dx will be 3x square. Now we need to get here du by dv. We have to find this one. Means this u equals to x square with respect to v equals to x cube. That means the question is asking you have to find du by dv. So du is in numerator and dv is in denominator, right? So what variable we have taken here? Dx. That means dx will be multiplied here. So if you cancel dx, you will be getting du dv. Which one you have to find. So du dx can be written as 2x, and here dv by dx is 3x square. So dx by dv can be written as 1 by 3x square. If you reciprocal this one, you will get dx by dv, which we have to substitute here. X and x got cancelled, so our answer is 2 by 3x. Okay, so du dv equals to 2 by 3x. So this is our final answer. Similarly, we will be solving for other questions also. First we have to consider one as u and one as v. Okay. Question number 2, u equals to sine cube x and v equals to cos cube x. We will differentiate this one with respect to x. So ddx of u will be 3 sine square x first, power constant, power minus 1. Now again ddx of sine x. So ddx of sine x can be written as cos x. So 3 cos x sine square x. dv dx will be first 3 cos square x, again ddx of cos x. So here we will get 3 ddx of cos x is minus sin x, so minus 3 sin x and cos square x. So dv dx will be minus 3 sin x cos square x. So this is equation number 1, this is equation number 2. We need to find du by dv. So du is in numerator and dv is in denominator, and what substitution we have taken here? Dx. So du by dx we have 3 cos x sin square x, and dv by dx is this one. So dx by dv will be the reciprocal part, 1 by minus 3 sin x cos square x. So 3 and 3 got cancelled, so negative term will come up. So cos x by sin x, that is, or you will cancel one term, 1 cos x and 1 cos x got cancelled, sin x and 1 sin x got cancelled. So in the numerator sin x is left and in denominator cos x is left. So our final answer dy dx, or here du by dv equals to minus 10x. Okay, so this is our final answer. Next question we have tan inverse 2x by 1 minus x squared with respect to tan inverse x. So you see, we have to substitute some term here in place of x, so that in the bracket we will be having in terms of tan. Now tan and tan inverse will get cancelled, then we will differentiate this one. And we know direct differentiation of tan inverse x is 1 by 1 plus x squared. So simply apply here. Let u equals to tan inverse 2x by 1 minus x squared and v be tan inverse x. Differentiate both sides with respect to x, that is ddx of u, ddx of tan inverse. Now first, before differentiating, let me take substitution and make it short first. Okay, first we will cancel tan inverse. Here you have to take let x equals to tan theta. So theta will be tan inverse x. So in place of x we will substitute now tan theta first. So u equals to tan inverse 2 tan theta 1 minus tan square theta. Now this is the formula of tan 2 theta. So tan and tan inverse got cancelled, we will get 2 theta. Here u equals to 2 theta, or u equals to 2, theta is tan inverse x. Now we will differentiate, du dx will be 2, ddx of tan inverse x is 1 by 1 plus x square. Let us consider this equation number 1. So dv dx, now we will differentiate this one with respect to x. ddx of tan inverse x is 1 by 1 plus x square. We need to find here du by dv. du is in numerator and dv is in denominator, and dx was the substitution. So du by dx will have 2 by 1 plus x square, and dx by dv we have 1 plus x square by 1. So this term and this term got cancelled, answer is 2, du by dv. Okay, so this how we will be solving differentiation of a function with respect to another function. In that case we have to take here u and v. So one function we will be taking in terms of u and one function we will be taking in terms of v. Then at last du by dv, that is du by dx into dx by dv. Okay, so we will move to next question now. Let u equals to, that is question number 4, tan inverse 2x 1 minus x square, and v sin inverse 2x 1 plus x square. In both the term here we have to take let x equals to tan theta, because if you substitute here tan theta, we will have 2 tan theta 1 minus tan square theta, that is tan 2 theta. And if we substitute here in place of x tan theta, then we will have 2 tan theta 1 plus tan square theta, that is sin 2 theta. So sin and sin inverse will get cancelled, we will get here 2 theta. Similarly here tan inverse and tan will get cancelled, we will get 2 theta. Okay, so what is the substitution? Let x equals to tan theta. If x equals to tan theta equals to tan inverse x. Now we will differentiate this one, ddx of u. First let us substitute this value. So u equals to tan inverse 2, in place of x we will substitute tan theta 1 minus tan square theta, tan inverse tan 2 theta, that is tan and tan inverse got cancelled, we will get 2 theta, or u equals to 2 tan inverse x, or du by dx will have 2 by 1 plus x square. because 2 as it is and ddx of tan inverse x is 1 by 1 plus x square. Let us consider this equation number 1. Similarly, here v equals to sin inverse 2 tan theta by 1 plus tan square theta. So this is the formula, sin 2 theta. So sin 2 theta equals to 2 tan theta 1 plus tan square theta. Similarly, tan 2 theta equals to 2 tan theta 1 minus tan square theta. If it is minus, then tan; if it is plus, then sin. Sin and sin inverse will get cancelled. We will have 2 theta, that is v equals to 2 theta, or v equals to 2 tan inverse x dv by dx, that is 2 by 1 plus x square. We need to find here du by dv. So similarly, du by dx into dx by dv. So du by dx we have 2 by 1 plus x square, and dx by dv we have 1 plus x square by 2. You see, dx by dv we need here, but we have here dv by dx, so this one will be reciprocal. So everything got cancelled here, 2 and 2 got cancelled. So 1 plus x square and 1 plus x square got cancelled, we get 1. That is du by dv. Okay, so this is our final answer. So here, function, differentiation of function with respect to another function. So first we will take u and v, then we will differentiate separately. So this is the second last class of differentiation. So my next video will be the last video tutorial on differentiation, then we'll move to next chapter. Okay, so practice well and you let me know your doubts, and make sure that these chapters won't be repeated as soon as the school gets reopened. Okay, so the chapters which already I have taught, that I will not repeat. So you practice well and let me know your doubts, so that I can help you in solving those questions.